Good day, Sir Bayon. I am Maika Remorosa, and today I'll be showing you my 3D models of three hydrocarbons, the methane, ethane, and ethane. So I made these models using toothpicks, clay, cotton buds, and a little blue dust for decoration. So these simple materials help me understand how molecules look and how their bonds work. So let's begin with the first model. We have the methane or the CH4. So it is like an alkane, which means all of its bonds are single. So I used clay balls for the atoms and toothpicks for the single bonds. Methane's shape is tetrahedral, which means it looks like a small pyramid with bond angles of about 109 degrees. So methane is very common. It's the main gas used for cooking and heating in many homes. So that is methane, CH4. So the next one, we have the ethane or the C2H4. So it has a double bond between two carbon atoms. To show that, I placed two toothpicks side by side between the carbon atoms. The shape of ethane is flat or trigonal planar with bond angles around 120 degrees. Ethane is important because it used to make plastic materials like polyethylene, which is used in bottles and bags. So I also added some blue dust around it to make it more unique and creative. So the third one is ethane or the C2H2. Lastly, this is ethane, also called as acetylene. It's an alkyne, which means it has a triple bond between two carbon atoms. So I used three toothpicks close together to show the triple bond. As you can see, there are three toothpicks. Its shape is straight or linear with bond angles of 180 degrees. Ethane is very useful in welding because it burns extremely hot when mixed with oxygen. So I also used cotton buds for the hydrogen atoms to make it more distinct and creative. So these are the three models. So now we are here in the reflection part. So the first question is, what are the main differences between alkanes, alkenes, and alkynes? When you say alkanes, alkanes have single bonds, alkenes have double bonds, and alkynes have triple bonds. So the second question is, how do bonds affect the shape? The more bonds between the carbon atoms, the straighter the molecule becomes. So let's always remember that. The third question is, why are hydrocarbons important? They are used for plastics, fuels, and industrial processes that we use every day. That is why it plays a significant role in various fields. The fourth question is, what are the challenges I faced? The hardest part was connecting the clay and toothpicks without breaking the shapes, but it was fun and helped me understand molecular structures better. So that's all for my presentation. Through this activity, I learned that the type and number of bands change how each molecule looks and behaves.